Welcome back. It's time to have a little bit of fun because you've just been listening to me talking for a bit and we want to get our hands dirty and try this machine learning ourselves. But even though we don't know much about it yet, we can actually play with it. For example, there's a great website here by Google called Teachable Machine. And as you can see, what it does is, well, it helps you do some machine learning activities. So if I click on Get Started here, and by the way, by the time you watch the video, maybe they've changed the layout of this website. It doesn't really matter because this is more for you to kind of understand how things work underneath the hood and even play with this yourself. So let's create an image project. And for now, all we're going to do is say, hey, I want to decide or create a machine learning model that detects faces or cats. So let's just say this is going to be faces and this is going to be cats. And we have to give it some image samples so that the machine can learn, right? So in here on my desktop, I've actually saved a couple of photos. I found a nice little cute cat picture online. So let's upload the cat picture. So we'll upload the cat picture here. You can see that we're only uploading one. And here I will upload the faces picture. We'll upload the baby's picture here. Awesome. So we have faces and cats, and then we train our model. We essentially tell the computer, hey, this is an example of what a face looks like, and this is an example of what a cat looks like. So just learn, please. So you can see over here, it's learning. And there you go. It now has created a model. Now in here, I can use my webcam or I can just upload a file. So let's just upload a snorkel picture that I have of myself and I click open. There you go. This model that we trained thinks that this has a 49% chance. Let's make this a little bit bigger. This has a 49% chance that this image is a face and a 51% chance that I'm a cat. What's going on here? What if we give it a better picture? I mean, this is a tough picture, right? It's a little bit fuzzy. I have my snorkeling mask on. Maybe it's a tough picture for this model to predict. So I'm going to upload a different file. Let's say this exact same face that I use in the image. If I click open, oh boy. That's even worse. It thinks I'm 57% cat, and it's 43% certain that this is a face. What's happening here? Well, what you've just witnessed is how machine learning works. We provide the computer some data. In this case, I provided one image of myself and Daniel's face, and one picture of a cat. Based on those two inputs and data, I say, hey, computer, learn, try to understand this picture, and try to understand this picture. And next time I give you any images based on this data, predict for me or tell me how much confidence you have that either it's a cat or a face. And that's pretty much machine learning. It doesn't have to be just images. It just needs to be some sort of data. We train the computer and we create a model that can predict for us based on that data. Now, we see here that it's really, really bad. I mean, this is definitely not a cat, right? So why is it bad? Well, think about this for a second. Try to answer it on your own. Ready for the answer? Well, number one is that we've only given it one image each. For a computer to really learn and to understand what a face is, what a cat is, it needs hundreds, thousands, if not millions of images of cats to detect patterns, to figure out, hey, this is what a cat is. Hey, this is what a face is. Right now, I've only given it one sample each. So this model is not very smart. Just like a human, right? To learn something in school, you have to repeat it. You have to see it over and over. And then also, with the preview, sometimes I give it a really clear image of a face, or sometimes I give it the snorkeling picture that's really fuzzy. So that also affects the output. But at the end of the day, machine learning is just that. We give it some input, and then we tell the machine to learn based on those inputs and give us an output next time we give it a new input. Now, I want you to take a break here. I'm going to link to this resource so that you can actually play with this yourself and see if you can improve this model. You can even have your webcam on, so instead of a file, you have your webcam, just like in the examples that they provide. So if I go to Teachable Machine, you can see here different projects that you can build just by clicking without programming anything. You can even export your model once you're done so that you can use it in your own projects. Again, if this is confusing, don't worry. We're actually going to go step by step, and instead of just doing something visually, we're actually going to code and learn how machine learning and data scientists work. But this is a great way for you to just understand on high level how machine learning works. So go off and play with this website, and I'll see you in the next video. Bye-bye. One thing that I really like doing in my courses is to actually understand the why of everything. Everything that we learn, there should be a reason we're learning it, right? And you might be asking yourself, why do we even care about machine learning? How is that useful, and how do we get here? Well, if you think about a business, because most technology evolves from business needs. We have the advent of computers and the ability for businesses to use computers to do things really, really fast and efficiently so that they gain an edge. And then we got spreadsheets. Spreadsheets like Excel files and CSV files were amazing because we can store data that businesses generate, such as maybe customer data, into an Excel file. And then people got really, really good at analyzing these CSV files, these spreadsheets, to make business decisions. Maybe forecasting that December sales are going to be high because, well, the past 2 years, we've had really high December sales because of Christmas. And then as companies got more and more data, we started getting this idea of relational databases. Spreadsheets were great. CSV files were great. But we started getting more and more information and data, and we needed a better way to organize things, to understand things from our data. That's when we got things like MySQL, which allowed us, instead of using spreadsheets, to use a language called SQL to read information from our database, write information to our database, but similar to spreadsheets, use the data that we gathered from the business to make business decisions so that our business becomes even more profitable. And then in 2000s, we had this fancy term of big data. We had big companies like Facebook, Amazon, Twitter, Google that started accumulating more and more data. An insane amount of data that you simply couldn't contain in a spreadsheet. User actions, user likes, user purchasing histories. This idea of big data meant that we had so much data. These companies had so much data. And sometimes, unlike relational databases, which had to be a structured form of data, sometimes we got really messy, unstructured data. And that's when we started getting this idea of NoSQL, where things like MongoDB came into existence, where you can store unstructured data and hopefully make business decisions out of that. Maybe if you were Amazon, you can use customers' purchasing history to recommend different products. And ever since then, this idea of data, getting more and more data, has turned us into using machine learning. Because at some point, we have so much data that as humans, we can't just look like we did at spreadsheets and look at columns and rows and make business decisions. I mean, we still could, but then we'd be wasting all this data that we've been getting over the years. So companies like Facebook and Google that collect massive amounts of data every single day are turning to things like machine learning, so that instead of humans looking at the data and trying to figure things out, we give this data to machines so that they're better able, even better than humans, to make business decisions. And this idea of machine learning really came to be because of this growth in data that we received from businesses, as well as the improvements in CPUs, GPUs, that is graphical processing units, and computer advancements. So using the massive amounts of data and massive improvements in computation, we can use these machines to give them this big data and make decision for us, just like we used to with spreadsheets. Now, this is a simplified version of how we got here, but I hope it gives you a reason as to why businesses like this idea of machine learning. Now, in this course, we're going to be using this framework. And don't worry, don't get intimidated. You're going to get really familiar with this framework because, well, we're going to talk about it a lot. But looking at this, just a brief overview, what do you think the hardest part is? Can you guess? It's this first part right here, grabbing the data. You see, amount of data is doubling every 2 years in our world. With the internet, all the mobile phones and connected devices, we're creating more and more data. But this data doesn't mean anything unless we understand it. Yes, we are producing data, but a lot of this data that we generate is unused. And that's what data science is. How can we use this massive quantity of data that is completely useless right now to something that is useful? And not all data is made equal, right? Some are noisy, some are messy. Where do we grab this data from? How do we find it? How do we clean it so we can actually learn from it? We need to understand what data is and then apply machine learning to it. And the industry is now evolving into these people that we want to be, data scientists. That is, people that can turn data from useless to useful. Welcome back. It's time to do a fun exercise, even though we've barely scratched the surface and we just started the course. We're going to build a YouTube recommendation engine, but our own. Okay, so how can we do that? Well, I have here a great website, a machine learning playground. And what we have here is a blank box. I want you to open it up. I'll link to this resource and try this out yourself as well. Now, let's imagine that on the y-axis here, it represents the length of the video. That is the length of the YouTube video. Now in here, we have the length, and across the x-axis, that is right here, let's say that this represents the likes on the video. So from less likes to more likes, from shorter length courses to longer length. And we look at our user's data. Let's say we have a user, Bob, and Bob likes to watch videos in this area. And he has clicked like on these types of videos. And with the purple, if I click on purple here, he has clicked dislikes on all these videos. Okay, let's think about this. So he has disliked a lot of videos that have lower likes from others, and videos that seem to be shorter in length. And he has liked a lot of videos that have really good likes, but tend to be longer in length. So if I click train here, and we can ignore all these little buttons and the parameters, let's just click train. This is what a machine learning model does. It tries to predict based on data. So we've given it this information of what Bob likes and what Bob dislikes, and we trained it to figure out the pattern so that when we now recommend a video to Bob, we know which ones we should recommend and which ones we shouldn't. For example, let's say a new video is uploaded to YouTube, and this video, well, right off the bat gets a lot of likes, and it gets a lot of likes, and it's super long, so it's right here. Should we recommend this video to Bob? Yes or no? Well, yes, right? Because from past data, we've learned that we should recommend any videos that fall into this orange category. But let's say there's some new data point. Let's say Bob starts watching new videos and then we see that, oh yeah, Bob also likes these videos, these videos. What happens? Well, let's train our model again. And this is the new model that we created. So now our machine learning model is telling us, hey, recommend any videos to Bob that fall in this orange category. You see, it's a little bit more complicated now. So with each data point, we're able to learn about what Bob's preferences are, and then train the model to decide if we should recommend and add the video to Bob's YouTube feed, or we should not recommend it because they're probably not going to watch it. What we've just witnessed here is us building our own recommendation engine. Now, obviously, this is a simplified version, but at the end of the day, this is exactly what we want to do. We give inputs to machines, and the machine decides and draws a line to figure out what we should predict for a future input. That is, a new video comes up. Should we recommend it to Bob or should we not? Congratulations. You just created your own YouTube recommendation engine. Kind of. Now, I want you to play around with this, play around with the parameters. Let's say we add 5 here and we train, we do decision tree and click train. Now, you don't need to know anything about these, just to play around and see what happens. And I'll see you in the next video.